Question number 19. Write the designation of an orbital having. They given principal quantum number n equal to some value, azimuthal quantum number L equal to some value. They're asking what orbital is this, like 1s, 2s, 2p, 3s, 3p. What orbital is this? Dear all, we need the help of this one. Azimuthal quantum number, L value, if it is 0, 1, 2, 3 corresponds to the orbitals S, P, D, F. Fix in mind. Azimuthal quantum number value, L, small letter L, it is starting from 0, 1, 2, 3. If azimuthal quantum number 0, it's correspond to S orbital. If it is 1, P orbital. If it is 2, D orbital. If it is 3, F orbital. If so, what is N equal to 5 and L equal to 3? That is 5F. N equal to 5, L equal to 3 means what, dear all? 5F. L equal to 3 means F orbital. Therefore, 5F. Next one, N equal to 4, L equal to 2. What is that? 4D. Dear all, N equal to 3, L equal to 0. L equal to 0 mean S orbital, dear all. So 3S. When N equal to 2, L equal to 1, 2P. So simple. So principal azimuthal to orbital, and orbital from which principal and azimuthal need to study how to write. Yes, dear all. Next go to question number 20. Which quantum number determines the following? Each quantum number, what are the quantum numbers we have, dear all? We have principal quantum number, azimuthal quantum number, magnetic quantum number, and spin quantum number, right? Each quantum number has some idea. Principal quantum number is give you the idea about the size of the orbit, right? The energy, size or the energy of the orbit. So size of orbit is given by principal quantum number. And shape of an orbit. Shape of an orbit is orbital, shape of the subshell, orbital, S, P, D, F subshell are given by azimuthal quantum number. And orientation of the orbital, the alignment, the arrangement, orientation of orbital is given by magnetic quantum number. And spin of electron is given by spin quantum number. These are the applications of 4 quantum numbers. Question number 21, dear all. Arrange the following orbital in the increasing order of their what? Energy. Dear all, energy order, if you want to arrange, there is only one rule in this structure of atom chapter. Which rule? Aufbau principle or N plus L rule. Energy. They given 3s, 2p, different orbital in the shuffled manner. We have to make them arrange in the increasing order of energy, means lesser to greater. Let us take our N plus L rule, dear all. Azimuthal quantum number starting from 0, 1, 2, 3 correspond to SPDF orbital. If so, 3s orbital mean, what is 3s orbital? What is the N plus L value? 3 plus 0. N value 3, L value for S orbital is what? 0. 3 plus 0, 3. And 2p means what? 2 plus 1, 3. 3p means 3 plus 1, 4. 2s, 2 plus 0, 2. 3d, 3 plus 2, 5. 4s, 4 plus 0, 4. Yes, we calculated the N plus L value of the given all orbital. Do you remember what is N plus L rule, dear all? Lower the N plus L value, lower energy. Higher the N plus L value, higher energy. If 2 orbitals having same N plus L value, the one with the low N value having lower energy. So, dear all, which one having least N plus L value here? All of you check it. This one, right? So 2s having lower energy. Okay, so 2s having lower energy. Okay, after 2, which one? 3 is there. But 3, there is a confusion. Both 3s and 2p orbital having same N plus L value, right? Now think about it. If the N plus L values are same for 2 orbital, the one with a low N value having lower energy. Which one having lower N value here, dear all? This one. So 2p having lower energy. So after 2s, 2p. Next 3s. Okay. Next one, dear all. Next digit is 4. Here also there is a confusion. There are 2 orbital with the same, the N plus L value 4. Which all? 3p and 4s. Among 3p and 4s, which one having lower N value? 3p, right? So 3p having next and lowest energy, then 4s, which one having higher N plus L value? 3d, that's having higher energy. What is this rule is called? N plus L rule or Aufbau principle. Question number 23, dear all. Let's go. What will be the wavelength, lambda, of a ball of mass? Mass is given 0.1 kilogram. Already given in kilograms, so no need to convert. Moving with a velocity 10 meter per second. Here the given quantities are lambda, means the terms are lambda, mass and velocity. Lambda m and velocity v. Connecting equation is our de-Broglie equation. What is de-Broglie equation? Lambda is equal to h by mv. You know, h is the Planck's constant, substituted. Mass is given, velocity given. Yes, it's a simple calculation. 6.626 into 10 to the power minus 34 meter. Clear all of you? So just de-Broglie equation. Next one, question number 24. Write the electronic configuration of chromium. You know, chromium and copper, there is two exceptional case. Let's study it together. First of all, chromium. Chromium, you know, dear all, atomic number 24. Normal way, when you arrange it according to Aufbau principle, you will get 1s2, 2s2, 2p6, 3s2, 3p6, 4s2 and 3d4. This is the normal way we are expecting. But there is a small exceptional case. What's that? You know, 4s2 means fully filled, but 3d4 means it's neither half filled nor fully filled, right? But when you transfer one electron from 4s to 3d, when you transfer one electron from 4s to 3d, what happened here all? It becomes 4s1 3d5. Now, s is half filled, even d also half filled. So, you know, half filled and fully filled configurations having extra stability. To attain more extra stability, they are doing this transition. So, dear all, when they asking chromium configuration, please write the second one. What about copper? Copper atomic number, you know, 29. Chromium 24, copper 29. 29 means normally we are expecting 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d9. But there is an exception. Transfer one electron from 4s to 3d, it give you 4s1 3d10. What is the property here? Here s become half filled and d become fully filled. So half filled and fully filled configurations having extra stability. To attain this extra stability, this electron transferring here. So this is the correct configuration of chromium, and this one is for copper. Question number 25, dear all. Which of the following has the smallest de-Broglie wavelength? You know, de-Broglie equation is what? Lambda equal to h by mv. H is a constant, v is the velocity. Only the changing one is what? Mass. Mass. What is the relation between wavelength and mass, dear all? Higher the mass, lower the wavelength, because they are inversely proportional, right? Because they are inversely proportional. Oxygen, hydrogen, proton and electron. Dear all, proton, electron has two small mass compounds, right? Hydrogen and oxygen are the biggest elements and the biggest masses. Among hydrogen and oxygen, which one having higher mass? Oxygen, right? O2. So oxygen having higher mass, so least wavelength. So which of the following has the smallest de-Broglie wavelength? That is for oxygen, because it have high mass. Yes, question number 26, dear all. What is the maximum number of electron in an atom having n equal to 3, l equal to 1 and spin quantum number plus half? Dear all, n equal to, you know, azimuthal quantum number value starting from 0, 1, 2, 3 corresponds to SPDF orbital. N equal to 3, l equal to 1 means which orbital? 3p. Yes or no? N equal to 3, L equal to 1 means 3p orbital. You know, 3p orbital, any p orbital, maximum it can occupy 6 electron. You know, any s orbital, maximum 2 electron. Any p orbital, maximum 6 electron. Any d orbital, maximum 10 electron. Any f orbital, maximum 14 electron. So this is 3p. 3p can occupy maximum 6 electrons, right? 3p can occupy maximum 6 electron. So among that 6 electron, just see once again all of you, among these 6 electron, how many electrons will be present with a plus half spin? 3p orbital contains 6 electron. Okay, but that is your answer? No. Among that 6 electron, half of the electron plus half spin, half of the electron minus half spin. So with the spin plus half, how many electrons will be there? 3 electrons. So the final answer is 3. Next one. Question number 27. Name the spectral line in the spectrum of hydrogen atom obtained when an electron jump from 4th level to 2nd level. As I told you, the spectrum Lyman, Balmer, Paschen, Brackett and Fund series of hydrogen. If the electron traveling from any higher energy level to 1st level, that's called what? Lyman. Any higher energy level to 2nd level is called Balmer. See dear all, here electron traveling from 4th level to 2nd level. 4th level to 2nd level, which means what? If it is stopping with the second level, that belongs to which series? Balmer series. Question number 28. How many radial and angular nodes are there in the 3p subshell or orbital? Dear all, what is meant by nodes or nodal surface? Node is a region where no probability to find an electron. Keep in mind, nodal surface means it's a region where no probability to find an electron. There are two types of nodes, radial node and angular node. Let us discuss detail about that. Dear all, radial node is also known as spherical node. Remember, radial node is also known as spherical node. What is the equation to calculate radial node? N minus L minus 1. N is the principal quantum number, L is the azimuthal quantum number, minus 1. Dear all, what is our orbital? 3p. 3p orbital means what is n value? 3 and L value for p orbital is 1. N value 3, L value 1. Substitute here 3 minus 1 minus 1. So 1 radial node. What is the equation to calculate angular node? Dear all, angular node is also known as planar node. That's equation is just L, azimuthal quantum number. So what is azimuthal quantum number for p orbital? 1. So there is 1 radial node and 1 angular node. Question number 29, dear all, write the value of 4 quantum numbers, all the 4 quantum numbers for the valence electron of sodium. You know sodium atomic number 11. Atomic number of sodium is 11. So what is the configuration? 1s2, 2s2, 2p6, 3s1. Which is the where is the last electron, valence electron located? In 3s1. Take 3s1. Dear all, for 3s1 orbital, what is the n value? 3. What is the L value for s orbital? 0. Dear all, if you know L value, how to calculate ML, magnetic quantum number? Magnetic quantum number ranging from minus L to plus L. Magnetic quantum number ranging from minus L to plus L. L value 0, which means what is magnetic quantum number? Minus 0 to plus 0, that is 0. And spin quantum number, you know, the electron, for the electron can spin with a plus half spin or minus half spin. We can write plus or minus half. So, they are asking only the outermost electron. Where is outermost electron located? 3s orbital. So, n equal to 3, L equal to 0. For s orbital, L equal to 0, right? If you know L value, remember all of you, what is the equation to calculate magnetic quantum number? Minus L to plus L. Therefore, 0. And spin quantum number will be either plus half or minus half. Question number 30, dear all. How do you distinguish the 2 electrons present in the same orbital? If I am giving you 2 electrons in the same orbital, how you can distinguish them? Just to look into their spin quantum number, dear all. You know, when 2 electrons are located in an orbital, you know, we will write with their, you know, first electron always plus half spin, second electron always minus half spin. So you can distinguish the 2 electrons in the same orbital by looking their spin quantum number. Yes, first electron always plus half, second electron minus half. Next one, question number 31. Calculate the number of proton, neutron and electron in this species. Bromine 3580. What is this meaning? Bromine is the element. 35 is the atomic number. You know, atomic number is the number of proton. So, number of proton already we found 35. What is this one? 80. That is the mass number. Mass number is the number of proton and the neutron. Dear all, this is number of proton. This is number of proton and the neutron. So, mass number minus atomic number, you will get the number of neutron. Okay, so what is the, in the case of, what is the, Z is the atomic number. What is atomic number? That is 35. What is mass number A? That is 80. And number of proton is equal to number of electron when if the species is neutral. Can you see there is any charges on the species? It's not a cation, it's not an anion, right? For a neutral species, what is the number of proton? That much electrons will be there. Okay, so number of proton is 35, number of electron also 35. How to calculate number of neutron? Mass number minus atomic number. 80 minus 35, 45 neutrons are there. Okay, easy one. Question number 32. What is the total number of orbitals associated with the n equal to 3? Principal quantum number given as 3. Energy level is given 3. What is the equation to calculate? There is a simple equation to calculate number of orbitals. Number of orbital is equal to, dear all, n square. That is 3 square. That's equal to 9. That's it. How many electrons are present with these quantum numbers? Dear all, n equal to 4, L equal to 2. Can you tell me which orbital is this? N equal to 4, L is equal to 2. Which orbital is this? That is 4d. Yes or no? 4d. And n equal to 2. Sorry, the alignment is different. N equal to 2, L equal to 1 means 2p, right? Yes or no? 2p, right? Yes. N equal to 3, L equal to 0 means 3s, right? Yes. N equal to 4, L equal to 2 means what? 4d. You know, any p orbital maximum 6 electron can occupy. Therefore, answer is 6. Any s orbital maximum 2 electron can occupy. So, answer is 2. Any d orbital maximum 10 electron can occupy. So, that's the answer. Easy, right? Question number 34. How many electrons are present with these quantum numbers? Dear all, n equal to 3, L equal to 1. N equal to 3, L equal to 1 and spin quantum number also given plus half. N equal to 3, L equal to 1 mean which orbital? 3p. Any p orbital maximum 6 electron can occupy. Among that 6 electron, 3 electron plus half spin, 3 electron minus half spin. So what is the number of electron with the plus half spin? There will be 3 electron. Next one, n equal to 4, L equal to 2. N equal to 4, L equal to 2 means which orbital? That is what? 4d, right? 4d, right? So 4d and 4d orbital. You know, d orbital when we writing, we will write 5 orbitals, right? dxy, dyz, dxz, dx square minus y square, dz square. 5 boxes we will write. 5 orbitals are there. You know, they given magnetic quantum number also. N equal to 4, L equal to 2 means 4d. Okay, sure. 4d means 10 electron can occupy. 2, 2, 2, 2, 2. Each 5 orbital, 2, 2 electron. If the magnetic quantum number specified here on magnetic quantum number minus 1. If they specified magnetic quantum number a value which indicate a particular d orbital among the 5. So this means it's confined to one orbital. In that one orbital, how many electrons can occupy? 2 electrons. So answer is 2. Next one, n equal to 4, L equal to 1. Think it, n equal to 4, L equal to 1. Which orbital? 4p. And magnetic quantum number given minus 1. Dear all, 4p. 4p. P orbital, we will write 3 orbitals, right? px, py, pz. Total 6 electrons are there, 2, 2, 2. But magnetic quantum number they specified. Magnetic quantum number they specified mean it is confined to one particular orbital. So there is just one p orbital. One p orbital can occupy just 2 electron. Among that 2 electron with a plus half spin, how many electrons are there? Among 2 electron, 1 electron plus half, 1 electron minus half. So what is the answer? Just 1 electron. Clear the connection? Question number 35. State Heisenberg uncertainty principle. It is impossible to determine the position and momentum of a moving particle like electron simultaneously. For a moving object, it is impossible to detect the position and momentum of this moving particle like electron simultaneously. That is called Heisenberg uncertainty principle. Statement and the expression is important. What is the expression? Delta x into delta p greater than or equal to h by 4 pi, where delta x is the uncertainty in position, delta p is the uncertainty in momentum, and h is the Planck's constant, pi is 3.14. And what is momentum, dear all? Momentum p is equal to mass into velocity, mv. What is delta p? That is m into delta v. Mass won't change, therefore m into delta v. So delta x into m delta v greater than or equal to h by 4 pi. This is the equation for Heisenberg uncertainty principle. So delta x into delta v, what we can write? M, you can take it in the denominator, h by 4 pi m. This is the expression and definition. Question number 36. Write the difference between orbit and orbital. Very important question, dear all. You know, orbit is a circular path around the nucleus where electrons are revolving. First, what is orbital? SPDF orbital. It's a region. Orbital means it's a region where maximum probability to find an electron. Do you remember what is node? Node is a region where no probability to find electron. Orbital is a region where maximum probability to find electron. And next one. Orbit represent the planar motion. Orbit, you know, it's a circular path. It's a 2-dimension. Whereas orbital is a region. It's 3-dimension. So orbit is 2D, orbital is 3D. Next one. All orbits are circular in shape or disc-like shape. Whereas orbitals having different shape. We saw that S orbital spherical, P orbital dumbbell, D orbital double dumbbell, etc. One more point you can add. The orbit, what is the maximum electrons occupy? We have studied in lower grade 2n square. You know what is orbit? That is your shell. KLMN shell. K shell 2 electron, L shell 8 electron, M shell 18 electron, and the N shell like 32 electron, like that you may study, right? KLMN orbit. So orbit electron occupation is 2n square. And what about orbital? Each orbital maximum 2 electrons can occupy. 1 plus half, 1 minus half. Question number 37. How many unpaired electrons are there in nickel 2+? Dear all, unpaired electron, right? Nickel is the system. Nickel atomic number 28. Let me write its configuration first. When you're writing the configuration of nickel, you will get 1s2. Just note it, okay? 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d8. You will get 3d8. But here the question, Ni2+. Ni2+ mean you're going to lose 2 electron. Their all outermost orbital is 4s. From 4s orbital, if you lose 2 electron, from 4s orbital, if you lose 2 electron, what is left? 3d8. 3d8 means d orbital contain 8 electron. How you are going to fill that 5d orbital 8 electron? 1, 2, 3, 4, 5, 6, 7, 8. After single occupation only, pairing can happen. Hund's rule. 1, 2, 3, 4, 5, 6, 7, 8. So can you see how many unpaired electrons are there? 2 unpaired electrons are there. Okay. So nickel configuration is, dear all, atomic number 28. You know, argon. Argon means 18 electrons filled, right? Remaining electron goes to 4s2 and 3d8. 4s2, 3d8. This is the ground state of nickel. But here the question, nickel 2+. Nickel 2+ mean we have to lose the 2 electron, which is the outermost orbital 4s. So remove 2 electron from 4s. What is left? 3d8. D orbital, how you can fill 8 electron like this one? 1, 2, 3, 4, 5, 6, 7, 8. So you can see these all are paired, these two are unpaired. So what is the number of unpaired electrons in nickel 2+ ion? These 2. So write the ground state first, then you lose the oxidation, means take the oxidation state, lose how much electron that you want, lose it, and remaining electron fill it properly according to Hund's rule, how many unpaired electrons are there. So dear all, it's a very important chapter, structure of atom, from your grade 11, chapter number 2. Keep practicing this question on all the numericals which we discuss here. Check it that the final answers are correct or not. Keep doing and keep practicing. Wish you all the best for your upcoming examinations. Thank you all. Bye.